Hi everyone, today's goal is to solve inequalities containing the word and or. A compound inequality with the word or means that one or both inequalities must be true. So here's the graph of a compound inequality. A is less than -4 or A is greater than or equal to 3. We would graph each one separately, okay, because the word or is here. So we have an open circle at -4. And since A is less than, we're going to graph or shade in to the left. For the other one, A is greater than or equal to 3, we have a solid dot at 3, and we're going to shade to the right. As long as a number satisfies one or the other inequality, it's going to be a solution. A compound inequality with the word and means that both inequalities have to be true. So the graph of a compound inequality, B is greater than or equal to 4, and B is greater than -1 is shown below. We put a closed circle at 4, and B is less than or equal to, so we're going to shade to the left. B is greater than -1 would be an open circle at -1, and we're going to shade to the right. And because the word and is in the compound inequality, we're going to take the part that overlaps, because in order to be part of the solution, the numbers have to solve both inequalities. Okay, again for the word or, it only has to solve one of the inequalities, either this one or that one. For the word and, it has to be able to solve both of them. So here we're looking for the intersection of both these sets. Sometimes compound inequalities are written out like this one is here. 17 is less than or equal to 2x plus 7, which is less than or equal to 29. When you have a problem like this, you're going to break it up into two separate problems. Take the first 2/3 of the inequality. 17 is less than or equal to 2x plus 7. And then the last 2/3 of the inequality. 2x plus 7 is less than or equal to 29. And you need to solve both of them. In between goes the word and. So you're going to solve the one on the right in the same way you would normally solve an inequality. And we would start out by subtracting 7 from both sides. We get 10 is less than or equal to 2x. Divide each side by 2. And we get 5 is less than or equal to x. On the right, we're going to subtract 7 from both sides. 2x is less than or equal to 22. Divide each side by 2, and we get x is less than or equal to 11. Because it was a compound inequality, the word and goes in between. So our solution set is going to be 5 is less than or equal to x, and x is less than or equal to 11. So when you graph this, you're going to put closed circles at both 5 and 11, and we're going to shade in the part that overlaps, the intersection of the two graphs that we've got from these solutions back here. Okay, here's another example. Here, what are the solutions of 3t minus 5 is less than -8, or 2t plus 5 is greater than 17? Again, you're going to solve each inequality separately. Here on the left, we're adding 5 to both sides. We're then going to divide each side by 3, and we have t is less than -1. The word or needs to be repeated between the two. It's important. Solve the one on the right the same way. Subtract 5 from both sides. 2t is greater than 12. Divide by 2, and we get t is greater than 6. Now we're going to graph these two inequalities. Open circles at -1 and at 6. We're going to shade to the left for our first inequality and shade to the right for the second. If you've noticed, when you have the word or, usually you're going to have two endpoints, and then we're going to shade on the outside parts in opposite directions. When we have the word and, normally you'll have the two endpoints, and then you're going to shade in between. Interval notation is another way to write our answers out, kind of like set builder notation. This is taken straight from your book, and I'm going to show you down here what all this basically means. Okay, if you have an inequality, x is greater than or equal to 2. Our graph, we're going to have a solid dot at 2, and we're going to shade to the right. Interval notation, we're going to put a bracket, meaning that we have a solid dot, and that 2 is part of the answer. And then we're going to put 2, comma, and because the number line goes on forever, we're going to use the infinity symbol. Whenever you use an infinity symbol, we're going to have to use a parenthesis for the interval, because we really don't know where infinity ends. We don't have a last number for it. Here's another example. X is less than 2. Open circle at 2. We're going to shade to the right. I'm sorry, to the left. Again, interval notation. A parenthesis, because this time we're using negative infinity to show that we're going on and on forever, to the left, comma, and then 2, our endpoint. 2 is an open circle, so it's really not part of the answer, and we indicate that with a parenthesis. 1 is less than x, which is less than or equal to 5. Open circle at 1. Closed circle at 5. And then we're going to shade in between. So our interval notation is going to have a parenthesis in 1, because 1 really isn't part of the answer, comma, and then it goes to 5, the other endpoint, where we're going to put a bracket. And the bracket's going to indicate that we have a solid dot here. 5 is part of the answer. And then down at the bottom, we have one that actually has the word or. Open circle at -3, because x is less than -3. The other part of the inequality is x is greater than or equal to 4. Solid dot at 4, and we're shading to the right. Interval notation again. Parenthesis, negative infinity, comma. Open circle here at -3. So that's our endpoint. Parenthesis to indicate it's an open circle. The word or is going to get repeated. And then for the right side, we have a bracket, because 4 is included in the answer, comma, infinity, because we go on forever. And again, whenever you have the infinity signs, we have to use a parenthesis with it. Okay, I want you to graph these two problems and write them with interval notation if you can. I'm going to be collecting them and grading them, so make sure you get them done. Do your best.